Hello and very good afternoon to all of you. I am Priyanshi and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group. Our today's webinar titled Simulation Technology for Fast Tracking EV Design and Development brought all of us together on this common virtual platform to gain insights from our experts on how innovative simulation technologies and tools can expedite the design and development of more efficient and performance driven electric vehicles. So, without any delay, it's time to start with the panel discussion. And for this, we are honored to have with us Mr. Yogesh Umbarkar from eTron Technologies, who is also the moderator for today, Mr. Sirish Bachu from Embital Technologies, Mr. Kumar Prasad Tekipalli from Matter Motors Private Limited, Dr. Savarananan from Mahindra and Mahindra, Mr. Harshit Bokley from E-Vehicle Mobility, Mr. Mahesh Sir from Automotive Research Association of India, and Mr. Ganesh Sir from E-Powertrain Simulation Expert. So, before handing it over to Yogesh sir, I would like to make a small announcement for all the attendees. If you have any questions during the discussion, please post them in the Q&A box. Our panelists will take this question at the end of the session. Now, I would like to invite and welcome all the esteemed panelists on screen and requesting Yogesh sir to lead the discussion. Over to you, sir.
Thank you, Priyanshi, and thank you, eMobility Plus, for giving me an opportunity to host this event as a moderator. And it's really pleasure to have everyone on the dais or now in the webinar panel or panel discussion here. So thank you for joining this panel discussion. I think as the topic says, is all about EV, right? We all know how the EV is getting penetrated in now all the segments. Earlier we were just talking about two-wheeler, three-wheeler, light commercial vehicle, but now you can see there is a lot of penetration with the Tata Nexon, if you take it, or any other brand. Everyone is launching their vehicles. So, and I believe that with the recent government push and their efforts through the policies as well, uh, it looks like all the factors are coming to support the EV growth moving forward. So, as you see about government PLI scheme or FAME 2, the boosting for the standardization and the interoperability of the battery swapping and so on. So it looks like, including the battery technology maturity going there, and I think most of these startup mushrooming where they have already gone through one cycles, where they now know that there is a good forecast projection. They have got good hold of the technologies, or they have got a good experience to build a world class products also moving forward in this context. So obviously we have various panel experts coming from a different industry, from the startups, from the tier one suppliers, like batteries, motors. We have a technology suppliers or OEMs, like Dr. Sarvananan from Mahindra, and so on. So today we would like to see that when all these players, when they started uh, building up the EV, what are the key challenges they have faced, and whether the simulation technology have really helped them, to what extent, and what are the use cases they have seen of simulations, which we would try to understand through this particular panel discussion. So just to start with, as the our topic is fast tracking on the EV development, maybe I would like to just play other role where we would like to really ask them whether the simulation technologies have really helped them. I think undoubtedly the answer should be yes, but then the answer would be to what extent it has helped them, and have they really been able to leverage it, or what are the key challenges they have faced. Maybe in general, I would like to go one by one. So maybe starting with Prasad, if you could give some background uh, on this question, whether the simulation technologies have really helped you, and to what extent and what challenges you face.
Yeah, thanks. Thanks for having me here, Yogesh. You're able to hear me, right?
Yes.
Yeah, great, fantastic. So I think most of the people in the industry, and I think you especially know that I've been a big proponent of simulation myself. Having previous roles too. But mainly if you look at it, when you talk about the overall product development cycle, and what is it that is the biggest challenge for anyone who is trying to architect a product. It's about predictability of what you want to get to, right? I mean, in terms of what there are attributes that you want to chase, then there are targets that you want to chase, but the journey in terms of what you are conceiving your mind to what you see in terms of a reality is a big gap in most of the cases. And you are essentially scratching your head to look at what's your MVP, right? What is the minimum viable product that you're looking at? And that's where I see that simulations, especially the system level aspects coming together, right? And when you look at a vehicle together, a vehicle getting conceived together, or you cutting a metal is always, from when your a design concept comes together, is a few months away, at least in the space that we are looking at, right? I mean, so it's that's where simulation essentially plays a role in terms of getting your architecture right, because while we have this very nice titles like CTOs, engineering managers here, essentially we are all architects, to be very frank. So I think that's one of the most important thing for from an visualizing what you want to realize. Then the second thing is, not everything that you can want to test is something possible in a physical nature. And uh, and there are topics where you want to build confidence on a virtual system simply because the element of testing and discovering it pretty late is even costly, and maybe in some cases you might not even get a test case you can repeat in a physical environment, right? I mean, that's where we have great tools which have come up, which basically helps you to look at what it is, again, trying to do with respect to performance. Then the third aspect, essentially, when you look at this virtual world, which is getting connected to with a connectivity scenario, data-driven scenarios, where your objective of serial processing of a product development is more becoming parallel. That means, I mean, in my times at Mahindra, I think the validation guy used to curse us to see, get a vehicle in their hands would be a 2 years journey before we actually get to the travel, right? I mean, but
Yeah.
if you look at it, right now you are essentially talking about a product development environment and a simulation environment where this data is also, actually a lot of data is processed in cloud too, right? I mean, and that makes information getting assimilated at different verticals at the same point of time, even enabling you to move forward in a parallel processing rather than a series by series conversation. So the validation guy essentially is able to take the same advantages in terms of designing his DVP. The more he is getting connected to a design analysis plan, it's not just a DVP, but how do you connect DAP and DVP? A design analysis plan and design validation plan. I think these are elements which are coming together, and I see practically from my journey, even at Eaton, Mahindra earlier, and now at Matter. I think we have cut down by at least 30 to 40% in terms of product development cycles, in terms of where we are, essentially because there are times where we were talking about CP, VP0, VP, TP, and a launch. Now you're essentially maybe compressing all of it without compromising on quality because of I mean, the improvement that we see in the simulation tools that are available with us. Now, but having said that, I'll come back. Not all is rosy there. You know, Finally, you'll have to get back to when you talk about issues related to EMIMC or multi-physics level simulations. There are a lot of topics which are systemic, which still need a very disciplined vehicle testing and validation uh, I think which is where we need to be very careful in drawing the line, saying that there is an importance to analysis, there's also an importance to validation, and it's our role as architects to stitch together to deliver right products to the customers. And that's what we do at Matter, by the way. Yeah.
No, very well. I think you articulated it very well, Prasad, covering up the various aspect, not just in terms of the how to leverage, but then how to understand the limitation of those software tools and then leverage it rather than just blindly believing totally simulation. And I think another good part I would like to just repeat and resonate with you very much because the way we are also seeing being coming from the Ricardo was like now the V cycle is really not remained like this left hand and then going on the right. There are certain things going in the loop now overall. So it's not a purely the V cycle which is getting followed in principle because as you say, there are some parallel processing. The data is available both on the system level, on the subsystem and component level. So I think people are trying to leverage that rather than going pure the traditional V cycle of development. So now thank you very much for all your inputs. Maybe I would like to come to Sirish, if you could give your insights.
Yeah, sure. Am I audible?
Yes.
Okay, wonderful. Great. So thanks, Yogesh and Kumar, for the lot of insightful uh, statements over there. Completely agree with what Kumar said, and also look, see, the fundamental thing which is happening now is moving to the electric. The traditional vehicle, which has been more around the mechanical IC engine and so on, so that is undergoing a change. And simulation in the automotive has already been there in practice. If you look at the structural simulations, what is required to build a vehicle, or the environmental simulations which are required to the overall EMIMC or the external thermal conditions and things like that. Now, with the EVs coming in, a lot more focus is coming towards bringing in a lot more software functionality into that, and that is where the this arena of functional simulation is taking much more priority right now. Though I would say it is not still mature in terms of the simulation tools and the overall ecosystem out there, but this brings in a lot of help because, like what rightly said, in terms of the time required to realize a system, to understand the behavior of a system, and also to characterize a particular system. So, because there are now, though EV on the face of it is very simple, we are bringing in a lot more complex systems together, and it's a system of systems. That's how it has become now. And that's where if you look at the battery management system or the motor control and things like that. Now there are already if you look at different phases, the design aspect of it. So because this is a completely new domain altogether and new what you call field altogether, there are not proven solutions which are out there. A lot of things are evolving, so you need much more capabilities in terms of assessing what is going to the likely outcome if I'm going to change certain parameters or certain design elements. And that's where I think there's nothing other than simulation what you can do. But if you have to go to build physical models and things like that, your product will never come out. I think that's the boon what simulation brings to the table. And second, very important aspect of it is in terms of the characterization, what you can build around this and bring in multidisciplinary impacts on these kind of software models. I think that's very, very important because in an EV environment, for example, if you're talking about battery, you're talking about battery chemistry, you're talking about the battery thermal behavior, you're talking about the packaging, you're talking of a lot of other electrical interferences which could happen and so on. And also at the same time, it has to deliver to certain functionality at a certain speed, certain demand, certain torque which is required, certain currents flow. So it's a complex beast. So if you were to now realize all this in physical world, you will go endlessly and not have your product out in the market at all. And that's where your simulation environments helps a lot in terms of building in all these things, parameters on platforms. Whether you go with the model based development, first of all look at the design element of it and validate your design, and then build quick prototypes to assess what is the physical behavior of that, and then come back and close the loops. And what you rightly said, the V is not V anymore. It's either flattened or else it's become circular now. Each and every touch point at every stage, at every hierarchy of whether you're looking at system or a subsystem or a unit level, it has to go with a closed loop kind of environment in terms of trying to quickly validate. And that's where the software defined vehicle takes a prominence. And we also talk of a lot of digital twins and this kind of terminologies coming in. It's nothing else but it's a combination of all these things put under one environment. Now, very important aspect also is once your product, let us say, is there and out in the field. Prasad mentioned about the field validation, where the validation teams are waiting for the physical product to come out. But now the cycles are also getting shortened, and the EV makers want to reach out to customers really fast, with one advantage being you're always connected there and you're always getting the real-time data from how the vehicle is used in the real world environment. And I think that gives a lot of powerful insights in terms of how your designs are really proving out in the field, and it gives you a very big chance to quickly correct your cycles or quickly correct your designs. So if say example is same vehicle is flying in Chennai, in a Bangalore or in a Delhi, the behavior will be different. This is very evident to, I think, all the EV makers out here. So it gives a quickly kind of either you create custom functional behaviors for those geographies or regions, or you look at the kind of issues which are coming in. It gives you a quick reaction cycle. Your reaction cycle can completely be reduced by making quick fixes and delivering the fixes over the air and things like that. And I think these are some of the benefits what the simulation platforms will bring. And of course, my experience has been on predominantly on the product side. I worked on the EVs as well, and a big promoter of the simulation, because if you are doing software, this is the way to go for you. And being a part of Embitel and being a part of the bigger VW group, also we are seeing a lot many global customers which are coming with many more such kind of requests that they want to accelerate the production cycles and accelerate the time to market and so on. And I think there's no other way to achieve this other than bringing simulations in this entire development.
So very well. I think, Shirish, you covered really broad spectrum coming from the not just the functional or multidisciplinary, but adding your view from the embittered on the broader aspects of the functional areas where how simulation can be used very well to reduce time to market and accelerate the EV development. So thank you very much. I would like to come back to Dr. Sarvananan. If you could share how you think the simulation have been helping you and why it should be part of your development.
Yeah, thanks, Yogesh. And I think my co-colleagues Bechu and Prasad has covered in detail about how the simulations will be definitely helpful with respect to the product development is concerned. Therefore, we'll see what other value additions I can able to do on this one. Similarly, if looking on to the simulations, definitely it is helping in terms of the reducing the product time significantly compared to that of the earlier days. Therefore, if you look on in the product cycles where we can do more number of iterations, validations, and testing, the simulations with respect to the tools available, we can bring down this time drastically, and multiple configurations or architecture can be simulated very easily. Therefore, for changing the component, either it may be for the motors or control systems, or different battery packs or battery technologies, whether it may be LFP or NFC, or different battery chemistries also. So for all these things, possibilities, if you do it on a real time on a proto basis, it takes a very, very longer amount of time. And if you look on the degradations of the battery pack, and if you want to, this can be done very, very easily with respect to the simulations. And not only the coherence of the simulation results with respect to the validation results also be matured or almost realistic, make enough to give a realistic kind of a data in terms of the field validation. Therefore, that significantly reduces the certain amount of the time. And not only it will helpful on the product development. For example, so if you're looking on to the applications, for example, when you simulate how my EV will work on with respect to this kind of a traffic or environment, what kind of a charging time it will take, what kind of a charging infrastructure which is available. Some customers avail about the range anxiety on this one. So for all these things, we can able to simulate with respect to the multimodal dynamics with respect to the EV. This will create a way that one customers will not worry on the EV infrastructures on a long term, and also the clear pathway with respect to the segments. So now earlier it may be started with the two wheeler, and now most of all the segments whatever it have been touching our are getting migrated towards the AV. That is a very good sign, and I think these simulation tools will definitely help in creating more kind of a products or portfolio in these segments, and also lesser time to achieve into the market.
Yeah, thank you very much, Dr. Savana. I think you rightly put up the specific to the battery and few other examples of testing EV in the different environment under different traffic scenarios. It will be very difficult to validate them without a simulation, because you cannot just create those thousands of scenarios, or you cannot accelerate physical testing of the battery degradation and so on. So yeah, I think simulation is cannot be replaced there at all. Uh, Coming maybe Mahesh, if you could give some perspective from the structural perspective as well, coming from your experience or thermal aspects, how and overall, because now ARI has also moved a lot in terms of their technology base, their capabilities, competency, both in terms of the testing and now the simulation, I'm sure of. So uh, how you have been experiencing, how it is helping you in.
Right. Thanks, Yogesh. With related to EV simulations or virtual product development, uh, I take this into two stages. One is structural, which is pretty much common as far as conventional vehicles are concerned, and all the codes that are presently in the market, they are all time tested, and they reasonably predict with very high accuracy what will be the structural performance in case of different events like crash, durability events, impact events, accidental scenarios, and that holds pretty much good even for the EV related EV vehicles. Let that be two wheeler, three wheeler, four wheeler, or HCV kind of applications. Second part related to EV, which was not there in conventional vehicles, is the powertrain. And when it comes to powertrain, there are good codes even available which predicts with reasonable amount of accuracy about the performance of EV. But what I felt is that, and what we experienced at ARAI, are even working with different EV OEMs and tier one suppliers of EVs, that there are two, three aspects of EV powertrain that really poses few challenges as far as accuracy and overall virtual product development only by relying only on simulation is concerned. So there we feel that you need to take some hybrid approach for especially for the EV powertrain related thing. One aspect is that, which is very important from battery safety performance point of view, is the thermal runaway. So thermal runaway is the thing which now, till today there is a nail penetration test for the thermal runaway, which will eventually will go in subsequently in different standards. As even now in Europe also they have started doing away with the nail penetration test. But nail penetration test basically is for understanding because of different parameters, say for example nail penetration, overcharge, or maybe over discharge, whether there is any localized increase in high current density, and whether temperature at the localized areas is getting increased, it is getting propagated, and a fire take place or an explosion takes place because of gases getting generated. So we know that the event of nail penetration, or for that matter a cell getting triggered, has happened. But from cell getting triggered till the fire happens or the explosion happens, this time is not yet getting predicted very accurately in the simulation. That means triggering of the cell can be captured very well, but the time required, because this time window is very much important even to give a warning signal back to OBDs saying that it's time to evacuate, or there is a within this time period people occupants should now have some escape plan. That kind of thing, I feel that it's there is still maturity in the code is really required to build this particular aspect. Second thing, which is related to range paranoia, or maybe I will say a battery life. Uh, in conventional engines, or conventional diesel powertrain engines, people used to say that it is 1:6 is the life, right? But here in it is now getting replaced with the powertrain. So it is only motor and battery. Motor we have been working since last 150 years. So motor is not a challenge. Battery is a challenge. So battery related life, that means I'm not saying life in terms of durability of life, but actually certain depth of discharge. For example, say a 30 kilowatt battery, after 5 years, whether that 30 kilowatt battery will become 24 kilowatt or it will become 20 kilowatt, that kind of accurate prediction, there is some maturity need to be built in for this, which will actually help for proliferation of EV related vehicles all over the world. If we can able to predict that this particular configuration battery can give a depth of discharge after say 8 years, it will get reduced only by 2%, for example, then that itself is a very much a selling point. That kind of thing, people do it by accelerated testing kind of a thing. But from simulation perspective, there is still some work need to be put in to do that. Third aspect is that we cannot do everything only through simulation, especially for the EV thermal performances are concerned, because we require something like HPPC kind of a data for cell characterization, and to understand the behavior of a cell for the electrical load or different charge discharge cycles, different cycles. So for that, tremendous amount of input data will be required in the absence of HPPC cells. So only simulation may not work for accurate prediction. It will work, but then you need to have a very accurate data. I think Prasad will also resonate the same thing what I'm talking, because we had earlier discussions with him related to this. Uh, the last aspect will be related to EMI EMC prediction. EMI EMC codes are really robust. Codes are really robust. They are predicting near field EMI EMC very good. But when it comes to far field prediction, because of the phase lagging, it is becoming difficult for accurate prediction, and lot of input data is required. What is happening is that all the input data is not in control with the EV manufacturers. In case of conventional OEMs, majority of the data is in their control, or they can demand, or they can dictate that they need to have that data. But for the EVs now, more than OEMs, more startups are coming for the EV, and they may not be necessarily having that kind of a commanding situation where they can demand a lot of input data from different battery cell manufacturers, or different battery component manufacturers. So with that data, absence of that data actually poses a challenge in accurate prediction of EMI EMC. And with respect to test, we are still 50-60% closer with whatever available data we have. For near field, we can go even more than 90%. But when the complete vehicle goes into a test chamber, and if you have predicted something, very certain that it will be 50 to 60% good, and rest of the 40%, again you need to come back and carry out certain modifications related to that. So these are some of the aspects what I felt is that that need to be looked into, or some more time need to be given to come to the maturity for the simulation codes to get it matured, and then maybe a complete virtual product development, the way conventional vehicles are doing, it can be more definitely. Simulation tools are very much required, because there is no background time tested data available for the EV vehicles. So presently, you will see more and more simulation tools getting used in the EV product development in the absence of the data available. But again, all the results like thermal runaway or EMI runaway, that need to be taken with pinch of salt, or maybe with that need to be used for comparison with A to B variants rather than absolute comparison with the test.
Yes.
With that, if we can go, then it will be much better from overall EV uh, performance point of view, its safety point of view.
Yeah. No, I think great. So thank you, Mahesh. I think I'm glad that you brought out the key challenges associated with the simulation tools. I mean, the
Yogesh,
limitations.
can I just add? I think
Sure, sure, please,
Mahesh
please,
made
please.
a very interesting point. Uh, See, I think one of the aspects in reference to the overall powertrain, right? I mean, uh, the thermal runaway is critical, while the battery side of it is getting a lot of attention. There's an equally bigger, our problem even with everyone going towards a permanent magnet machine. Okay, I think not many people really relate to it, but most of the people who have looked at the data of what's happened in the last 2 decades, be it hybrid powertrains or even on the ev machines, you will see that you know the rpms of the electric machines are getting higher, and there's a great demand for you to get into a field weakening zone, right, which enables you to operate in a higher speeds. Now, when you get to a high speed electric machine, you are essentially, in most of the times, using, especially in permanent magnets, you are actually using a d-axis component of your current, which is demagnetizing the flux all the time to achieve these high speeds. That what many people relate to as performance loss and attribute to only the battery packs essentially also comes back to a thermal plastic effect on magnets actually losing their remanence flux. Okay,
Yeah.
and 99 percentage of people who actually look at the data end up debugging battery pack alone without paying attention to what is happening to your electric machine and the torque producing component too. And they come back with math saying that, Array, I'm able to only come back to and relate to only 70-30 percentage of the issue. Now, if you had a robust model and you are actually doing this prediction in terms of life cycle, not just at a battery cycling effect, but you are actually looking at a powertrain system level, right? You are essentially able to do this prediction much better, and that data is going to stare at you if you have a very good model on an electric machine too. Okay, that's an opportunity that industry has to really realize as the power of simulation. It's not about getting from 99.99% to 100% or 99.9% reliability at 90% confidence to 95%. That is not where simulation is going to help. Simulation is essentially going to give you a directional indicator of what is the key CTQ that you need to factor, and how do you pull in your data heuristics. Okay, and I mean, Mahesh also mentioned about the data being a challenge, but right now it's an opposite scenario in India. In the industry, there's a lot of data. What data do you want to make sense of? And how do you bring it back into your ecosystem to, use the 20 percentage of information to make 80 percentage of your predictions right? I think
Yes.
that's more crucial for us, And sorry for jumping in, but it's something very core to my heart, where I've burnt my hands. So I just had to jump in here.
No, then that's exactly what we want, because at the end of the day, we need a more devil's advocate and then the normal advocates who can really challenge each other. But then, in principle, I really support you, Kumar, because uh, there is a data available, and now at the end of the day, we just need to see that how we can leverage and build on that data. You cannot have a, because as I think Mahesh was mentioning, that you don't get a data, but even from the sales suppliers to the OEM typically. But even what I've seen is the sales supplier, whatever the data is giving, is just from the one set of batch. Okay, from batch to batch, there is a variation. So we cannot go to that level of absolute scenario. You need to start somewhere and build on that assumptions, refine it as you get more test data, and a lot of things on the actual vehicle also. So now, I mean, in terms of just the way the situation is becoming more of that this simulation will not be just used in the engineering, but now we are with the cloud and connectivity, both on the vehicle and the powertrain front. There is a lot of prognostic will happen, which that data can also be used further in the design stage again back to. So that loop is going to be a much more dynamic now as compared to the engineering separate and real after production. We don't care about the data, what is happening in the field, or that data was not really being leveraged by the engineers. But now with the data available to that accuracy level from the vehicle or powertrain or battery and motor, that is more likely to get used and help refine the product, not just refine but develop your product for a future generation of the products as well. So no, I think it's really great, Mahesh, and thanks Prasad for chipping in and adding the valuable views there. Maybe I'll go to the Harshad, because there was a one thing talked about startups, and I think Harshad is one of the key member who have already seen the battery development in his previous experience at Sony, and now building up his own product through e-vehicle. So maybe Harshad, how you see your journey, and what are the key challenges, or how you have been able to leverage simulation? And I'm sure the simulation tools are now not that cheaper engineering tools. They are expensive, right? And then to get that utilization and to get that expensive tools utilized for product development, and at the same time it reduces the cost, but then that upfront investment, how you are able to manage it. So can you share your experience?
Yeah, thanks Yogesh for coming up with this issue, because as Mahesh also correctly said, there are so many startups in EV design and manufacturing now, and startups always work in a resource constraint zone. Okay, so the simulation tools, very good simulation tools, are boon for companies like us. But as you correctly said, those are not come at certain costs. So initially, when we started working 1.5 year back on our three-wheeler cargo, we of course build the vehicle model. So at that time, purchasing say a good simulation tool like MATLAB and all those its toolboxes was not a very good option. As a very beginning, we were doing the bootstrapping. So we initially go ahead with the open source software. Even now, open source software have reached to the maturity that we can reliably use it. Of course, we had to see which version is stable. So we initially work with the Scilab a lot, and again, many of our esteemed speaker already have said that closing the loop is most important thing. Is designing your entire vehicle and powertrain based upon the simulation data is not a good option. You have to close the loop somewhere. So for that purpose, we actually built a Proto Zero, which was a scaled down model. We took a extensive data. Since we are a startup, we didn't have a legacy data with us. So we took all the data, not just electrical but also the mechanical data. We put that back into our simulation, and then come up with the final specification. Now the problem comes when you are, so it's good that you have designed a model, you have designed you have decided the specs, but what about getting a confidence about the range that you want to go the range? Or there are so many competitors, you have to go to the customers, you have to get the potential customer. How will you confidently say it to them? So again, one innovative thing that we did at Avical was we build a electrical powertrain. That's a mock-up electrical powertrain. We put it into the hardware in-loop simulation using dynos and using other simulation softwares and hardware. And we were actually able to gauge the actual range of the vehicle, not just is the cycle defined by area, but also the real-life road condition range. So that has boosted our confidence a lot. And I would say with the use of this simulation tool, we have cut down the time by 6 to 7 months for a vehicle development.
Oh, wow.
So that's a huge cost saving and a very faster approach for us. And there has been so many discussion about data, the enormous data that we are getting, and it's very important now. So your electric vehicle is getting more closer to the smartphone, I would say, rather than Maruti 800. So a lot of data is coming, and we are not just stopping at the vehicle design or development stage for simulation. So we are also working upon making the digital clone of a vehicle itself. Let it be a battery, let it be a motor. So Prasad very he said not just a battery degrade but also motor degrades. So that point we understand very well. Although most of the motor manufacturer will say 10 years you don't need to worry about the motor, this. But doesn't happen. There is always some degradation. So we are using the digital clone of our vehicle to include a deep learning with our vehicle control unit, and that is able to give additional value and additional revenue sources for my startup also.
Great, great. So thanks, Arshad. I think you've given a good idea that how you have been leveraging the simulation and particularly the open source tools available. I'm sure it would have been slightly trickier first time, but once you get used to and you know the how to use it, you could leverage those tools as well very well. And then one of the another point which you mentioned was the leveraging the deep learning or the other machine learning algorithms to leverage the, the simulation tools or digital twin, not just for engineering, but also for a real world prognostic and diagnostic purpose as well. So that's really great. One of the point which you mentioned about the motors, and then we have one of the veteran motor specialists, Ganesh. So maybe Ganesh, can you help us understand how you've been seeing? Obviously, we talked about a lot of things on the battery. I think most of the previous speaker talked about battery issues in the EV. So, what are the key challenges which you see from the motor development for EV, and how your experience is that how simulation tool can leverage or help in the motor development and ensure the motor failure doesn't happen, not just the battery, but that's what the comments coming up. So
Yes.
please help.
So it's like motor is the one key heart for the vehicle, I can say. So we have motors for more than 100 years. We are in the field of motors. We are using motors for different applications. When it comes to EV, the operation is entirely different. When you make a design, you need to consider those aspects in the design. So if you can't able to make it a classical motor design into a EV motor design, so that constraints you need to take it when you make a design. By using the simulation softwares, we can able to predict those things, like how we said, Kumar and other people, the degradation, the magnet degradation, we can able to easily predict by using only by simulation. If I go in real time, how much current when d axis goes, when it's going to degrade my magnet, those things I can able to predict only in simulations. And also it's like I can able to see when it's going to fail, what is the life cycle it's going to fail. So those things I can able to do only by simulation instead of going to see the real cycle. Because if I want to take a motor, build a motor, keep it in the rig, testing it for about 1 lakh cycle, which is going to be a quite long period. The same thing if I do it in simulation, I can complete it within less than 4 to 6 months time period. I can able to complete, okay, 1 lakh kilometers is run. This is the data. This is how it's going to be. This is how it's going to behave. This will make us to easily predict, okay, this is the failure. How we can able to avoid those failures in the real time. And also now it's not like a motor failure or battery failure. We need to have a consortium where we can able to exchange the data between the motor company. Need to share the data to the battery companies. Controller companies need to exchange the data. By making these exchanges, what we can able to is we can able to do a real time simulation, like a system level simulation softwares like a Ricardo or Amisim or GDSO, where you can able to put it, where we can able to see more realistic data information. How much range it can able to give, what is the thing we can able to make it, what are the things we can able to constrain over there. All those things we can able to do only by simulation. Otherwise, what will happen? It will be like a black box for motor, battery and motor and controller black box. For motor guy, battery is a black box. We doesn't know how it's behaving, what is the thing it's going to be, how it's going to operate. So that's what, when we exchange these data in simulations, it's easy for us to understand. Okay, this is how it's going to behave. This is the operational condition. When it's going to hit the peak, when it's going, we can easily define. Okay, this is the vehicle level requirement. Okay, this is thing is required. By simulation, we can easily convey the message to the manufacturers of vehicle, to the manufacturers of battery. What is the demand from the motor? That can be easily communicated only by simulation. Now it's like earlier motor design is like only electromagnetic. It's not only electromagnetic. It has structural, it has thermal, it has system level. Everything has to be plugged together. They need to undergo a complete cycle of this to complete a single motor, which I make it in a real time will take a longer period. My proto will take more than 2-3 years. Now by using simulation, I can easily predict, okay, I can fix up my time for electromagnetic simulation, and at the same time I can compare different technology of motors. It's not only like permanent magnet based motors. I can able to check, okay, permanent magnet radial motor or axial motor. What's the benefit I'm going to get? Which is going to get a better range, better benefits to me as a power to weight ratio, torque to weight ratio. Then
Wow.
it comes to switcher electrons motors, then flux switching motors. Then now people are more looking on one field synchronous motors, where BMW, Renault, they are started working on those particular concept where they want to completely avoid the rare earth part we can able to completely avoid. So that's how the technology. These technologies, if you make each and every time the motor built and making things, which will be a longer period, which will take more time. Where here I can able to make the things like quite faster. When it comes to permanent magnet motor, we have a different grades of permanent magnets,
Yeah.
different grade, different temperature level. So what's it's going to operate, how it's going to operate. If I want to reduce my magnet degradation, how it's going to give the performance. Those things I can able to do only in simulation. In real
Yeah.
time, it's very difficult to make it.
Make
Making 50% of degradation of a magnet, doing my real time, that's very difficult to do it in real time.
yeah.
Those things I can able to see only in my virtual, where I
Virtual.
can able to make it faster. So I can able to predict my results more accurately. If it's going to fail, if it's going to degrade, what is going to be my effect of the vehicle, how it's going to make it. That thing can be predicted only by simulations.
Yeah. No, great. I think Ganesh, being
Yes.
coming to you, got into good technical aspects about the motor, and thanks for sharing your views. And I think that one of the important point which you made, and I used to also think that that should happen more and more. Although, so in terms of the interaction, not just with the, because what is happening is the motor and the OEM guy, like motor supplier and OEM, they interact, but there's that triangle of the powertrain, like battery, motor, and OEM, they all should interact. Then only you can achieve the real optimization of those subsystem or component on a vehicle level. Otherwise, there'll be always some gap would there, or uh, you cannot achieve the full optimization. That's even my thought process. I think Arshad, you wanted to add some
Yeah.
comments.
So yeah, the just wanted to pitch in. So Ganesh has put very good point. So everything is not possible to do in real life. So this actually very true when it comes to the after design. When we want to take a right now it's not possible to model a vehicle purely using by physical equations. There are so many so many parameters there. So the best way is to go for deep learning or machine learning, and for that particular purpose, the amount of data that you can put to train your data, the best result you will get. So for that purpose, again, same thing. We are running the digital clone through different scenarios with different angle, different weight loads and all. So this is helping us a lot. And yeah, it's very important if you someone wants to go into this area. Just to share, like one of my first employee that I opened a job for, that was for a simulation engineering.
Okay.
So yeah, it's
Yeah.
a very important part of vehicle development.
Yeah. I
Yeah,
think
on
even
this note,
I got that feel because in between, I think 2 3 years back, this DIY guru, the guy who is running these online platforms for training, I think he made a survey, and the he said that 63% of the requirements were started from the simulation. So that every OEM or tier one was looking at a simulation engineer, CE engineer. It could be system component level, but the requirement was on the starting with the simulation overall. Now, one of the important point what Harshad you made is in terms of the deep learning, machine learning, and we have a Shirish where his Imbitel is really developing a unified operating system platform, not just from the powertrain. I think the overall system per se on the vehicle, right? So I'm sure he would be working on a lot of digital twins, both physics based and the data driven digital twins. So maybe Shirish, can you help us how uh, you've been utilizing these digital twins apart from the just EV development in other areas? Maybe some one example to give us idea more. General example could be
uh,
also.
see, generally that's what the digital twins. I think in the automotive world, it is now fast catching the prominence. That's one because it gives you the flexibility to characterize, to model, and understand the behavior overall as a system, and like what I said earlier, at a subsystem levels in terms of interactions which is there, right? So there are two parts to it. When I look at the way we're poised at MBTL, one is of course we are now part of the VW group and Carrier, which is building like what you said, the overall operating system for the car and the platform, which is a completely native platform and which will go across different brands. And there, of course, the whole point is how all these things are coming together and culminating on one single platform, where one fundamental enabler is at a OS level, how can this be commonized? But second, when it look at the application or the domain level, whether it is a cockpit related or whether it is safety related or ADAS related, these are the areas where a lot more digital twins are going to be used or getting used. And that's where when you specifically look at the ADAS applications, a lot of new applications are coming in, but in terms of how the real life behavior is, we cannot go onto the road and kill some people and then find it out, right? So that's where the digital twins come into play very heavily there, in terms of looking at validating your algorithms which are there, and then looking at the overall interaction behavior across in a given environment. And these environments can be changed with different scenarios, what can be brought with the different data elements. So this environment building becomes very kind of flexible when you talk of the in a simulated models which are there. The other aspect of it is when I look at the global customers, what we have and the kind of solutions what we are providing across, where in terms of, there are pieces where they want only one small piece of a model to be built and then validated and so on, whereas some customers come to us with a complete end-to-end solution where they want the complete platform and things to be given to them. So overall, what I'm saying is the adoption is much more because of all the benefits what we spoke about in terms of the flexibility, in terms of the predictability, what outcome would be there, and so on, and also. But one critical element, I think, what Mahesh, sorry, not Mahesh, uh, so, our one second, Harshad spoke about in terms of the data, and also uh, uh, Mahesh was talking about it to a certain extent. Uh, One element is we are talking of everybody collecting a lot of data, and especially for a startup, it becomes very difficult when you look at the initial stages. You don't have much of the field data, and that's really a struggle to build upon, because your simulation or the models are only as good as the kind of a data which is available to them. So it's like garbage in, garbage out, right? So you may have wonderful models, but then if there's not sufficient data, you can't do much. And by the time you take to capture that amount of data, your timing is running out. At the same time, as a ecosystem, if you look at somebody like ARI, which is sitting out there and which is kind of a central interface to everybody, this is a suggestion you can think about, Mahesh, is how can we enable the ecosystem players by getting access by mutual enabling and putting all the data on one platform. It need not be the confidential, it need not be proprietary, or it need not be business critical ones, but then there's so many things people rediscover themselves, right? A lot of rediscovery happens. So can we put all of them in a single platform where people can have access to this data, so that their development cycles and their learning cycles can really leap forward? And as a country, we can really look at how we can accelerate this entire EV ecosystem by enabling the development cycles. Enabling this maturity of the product is a big challenge for all of us, and each one of us is struggling. Perhaps this is an opportunity where we can come together and create something which can be useful and holistic for everybody, and then pull in here.
Yeah, no, great. I think it's a great suggestion, Shirish, from your experience, and I think that's something. I think the towards the common goal. I think all the OEM tier one suppliers they need to look at. Maybe I'll probably towards our given the time constraint. Probably I'll lastly come back to Prasad, and I'm going to him because we talked individual views about tier one suppliers, the OEMs, to startup as well. But now maybe Prasad is a unique place guy here, where he is coming from a very established background, experience from the Eaton, Mahindra, and so on. But now he has gone into the startup mode where how as a CTO co-founder, what were the key challenges? Obviously, I know you are a key simulation promoter, but then what were the key challenges when you started now from scratch in developing the overall ecosystem of engineering and using the simulations? What were the key challenges associated, and how you managed it? If you could share your experience.
Yeah, I think it would be easy if I said it was a piece of cake. But I would be, bluffing there.
Just
But
give a purchase order and then
yeah, exactly.
let the engineer do the work. That's all.
Yeah. So I think it's a very important question, and thanks for asking this, Yogesh, because I'm definitely I'm speaking for Arshad and everyone else who is in the startup ecosystem here. See, one is I think it's there is no substitute to getting your thought process together on a drawing book, in terms of how do you want to approach, because the randomness of things that come in front of you are so many that you can get distracted pretty soon, and you burn money without knowing where the money is being spent. I think at Matter, as you rightly said, we have advantage of being both the tier one and the OEM too. In our case, and for right reasons, we have actually kept key portions of the intelligence and powertrain in-house, including motors, battery pack, power electronics. We are developing grounds up at 0 feet level in terms of technology. So the conversations with us in terms of technology partners are with Texas, Infineon, or Qualcomm, and these guys. So sometimes it makes it easier, when you want to architect at that level. But it's not always easy to get in the game when you have to bring the entire product right from the component also up. I think that's where it's very important to be in a win-win approach. You really have to develop a lot more partners. You have to really look at who are your people to trust with, and who can tag along with you in terms of this development journey. And even on the simulation front, though Harshad, I think it's a brilliant idea that you guys have also used open source tools. Everyone does that, but I think the simulation community also has stepped up quite a bit, be it MATLAB, be it GT. I think the way they've constructed the startup packages, which are extremely important to make sure that the organizations like us are successful. I think we would have been bluffing to say that we would have progressed to the level that we have if we did not have right partners with us, right? I mean, in that way, I could see that the way the not just the government, which is helping startup with the startup initiatives, but also the partners who have come up with packages which are very meaningful in terms of how you can adapt, because there's a no-brainer right now in terms of architecture story that we spoke about, right? There's no way you're stepping out of it and getting your architecture right. I think that's one big enabler in terms of partnership. And in terms of overall ecosystem, I think if I have to pinpoint on one element which is also helping is the academia part of it, how vibrant it is right now,
Yeah.
right? I mean, 5 years back, if I, at my seat in Eton, if I'm talking to, universities to talk about students coming with a very strong GT experience, you're pinching yourself, even 5 years back. Okay. Right now, I see that the penetration levels of these guys into the academia has enabled us to get very good talent, to come in, and very good talent which is not corrupted by 10 years of baggage. They're fresh thoughts, very agile people, and equipped with the right tool set to actually start working on contributing right from the day zero. I think that's something which has been helping us in our journey too. But again, it should be a real mix. So if you look at my organization, you have postdoctoral, doctoral guys, architects who are actually sitting on top, basically taking the architectural calls. And then you have very agile, engineers coming in from reputed universities who are because of the collaboration that has happened with the simulation guys, they're ready already the day they join, right? I mean, it's not like ANSYS training and others have to start on the day they are on the job. So that has helped a little bit, but again, if you want to be a tech-based startup company, right? I mean, your investments also have to be always measured. You can't shy away from them because you need to have a roadmap. You can't just be a one product pony, in a way, right? I think that's where we are, at least, from our perspective. And I think I can talk for many startups too, where the evolution is in terms of where do you put money and how does it become as a contributing factor to a roadmap, not just one for one product. I think that's where there's a lot. I think industry is also going to learn from what startups are going to do. I'm just putting my neck out. and saying this because uh, it's the disruption that's happening in terms of how you're utilizing your time and resources to do most with a little. I think is going to disrupt the entire industry to come back and think, what's the right way of managing your resources to the getting maximum output there. Now, I think, one element that I, however, want to touch upon is there's no substitute to design for Six Sigma. There's no substitute to design for robustness. There's no substitute to design for safety. And these elements, I think, people who have burned their hands like Shirish, myself, I'm sure, ARI, a team and others, I'm sure we have burned several things to ashes than what we have made. Okay. And that the what we have made is coming from what we have actually tested and validated, and how we are using that information to build better simulation models. I think that's something which we have to really connect the entire circle to say that, okay, we need a right balance and a handshake which is meaningful, and right partners also to support. If anyone is saying that I'm solo in this game, I'm sorry, we are not. And I have two partners here, in Shirish and ARI, who've been working closely with me also at Matter. So that's how things will work for any startup.
That's great. I think Kumar, you shared your experiences and all in a very broad way in terms of the partnership, the collaborations, and how the ecosystem you're trying to build, not just from the one product, but then overall roadmap perspective, because it cannot be just short-term view, because as a tech company, you need infrastructure for a longer run as well. So thank you for sharing it. I think with this, probably we can now move to the question answer session. Given the time, obviously we have a very limited time available. Sorry, Priyanshi, but I think it was good to get the views completed from the panel. We have
Absolutely.
a
So
we have a
I'll
question.
just
Yeah, go
so
ahead, Priyanshi.
okay. I'll just display one or two questions on the stage, and we can take it, and then we can wrap up the session.
Yeah, sure, sure. I think maybe yeah.
You can
Okay,
just scroll down to see the
who
full question.
maybe who would like to take that?
Prasad, would you want to go at it?
Sure. I mean, so uh, yeah. So the see the 48 volts, fortunately, has really come to a sweet spot. Especially in automotive industry. I don't know who, but someone who has thought through very well has defined that line at 60 volts in terms of saying that, okay, anything going above 60 volts becomes high voltage, and anything coming below 60 volts become 48 volts. There's a lot of science behind it. I don't want to get into a science conversation here, but essentially the beauty with 48 volts is it is the right voltage level where a lot of power density related challenges can be addressed for issues that are connected to a level of mobility that we are talking about. And hence, what you can see is both in terms of power electronics, motors, and battery packs, there are sweet spots emerging in terms of the sizes, at least. The only challenge in the industry is, it's almost like a jewelry, right? I mean, everyone likes his own set of jewelry, so there's hardly any stronger push towards an battery pack level or electric machine level standardization yet. Whereas when you come back to the building blocks, right, when you talk about cells, MOSFETs, diesel capacitors, or there is a lot of elements which are emerging there. But in terms of controller architectures, now this is on the hardware front, but the controller architectures are pretty stable. I mean, BMS, you're talking about motor controls, you're talking about even the supervisory, controls in terms of onboard chargers and others. They've come to a very, very, clear definition, both in terms of hardware, and the software aspects, which are key, in terms of the standardization portion. But I would still say that there's a lot left, when you start stretching the imagination towards a battery swapping scenario that the government is trying to enable. Are we really at it where you can think about pushing a battery quality, battery pack of quality X along with a battery quality or battery pack of quality Y into the same charging, swapping station, you might be creating an a scenario where you're disrupting the entire swapping world, uh, because it comes back to the same level of build architecture and validation cycle that happens there. So I think there's a lot yet to be done there. So I would say we are 50% through the journey here, and I'm also happy that there's not too much of standardization done, because there's not so much of innovation that happened too. To be very frank, the moment I hear a lot about standardization, I'm worried sometimes. If you standardize too much, you're basically also taking out opportunity to innovation in terms of what can be a set path
Yeah.
versus what can be really an opportunity to evolve. So the remaining 50%, I think, is opportunity for people like me, Mahesh, and Sirish to see how we exploit them and generate more other products which are much more future looking for us. Yeah.
Yeah, and I think by and large, also 48 volts is pretty popular in the two-wheeler segment because of all the points what Prasad has already mentioned. But when it comes to the four-wheeler passenger car segment, it's a different ballgame altogether. So each one is having their own benchmark, 72 volts, going all the way up to heavy commercial trucks, 700 volts, and so on. So I think, Prasad, that is where I would bat for more for standardization to at least have some kind of a uniformity across the industry, whether in terms of the overall the sizing of the components or in terms of the interfaces which come across, so that there is some kind of a plug and play possibility going into the future.
Absolutely. Yeah.
Good.
Yeah.
Yeah. Maybe can we go to the next question, Priyanshi?
It's
Okay. Maybe I would let uh, Mahesh. Would you like to comment from the area
Yeah,
or
sure.
area academy
Uh,
per se as well?
Right, right. The question is related to where we can get a good platform to learn about EV like courses. So ARI, we have ARI runs an academy, which is called as ARI Postgraduate Academy, and also now we have started giving some undergraduate degrees also. So we run one course specifically for the EVs. It is a 1 year duration course where the more focus is only on the EV, more on electronic side, BMS controllers, and where the students will get exposed to what are the real life problems of EV, how the EVs are getting integrated, and they get all the hands-on related experiences, which otherwise is difficult for them in regular academics, which whatever stream they are. So as this is being very focused only for the EVs, only EV related topics will be covered in the curriculum, and hands-on is also related to only EVs. So that the EV manufacturers, tier ones, they will be very useful. Student batch will be very useful for them, and they can directly deploy them for the actual work rather than spending much of a time in training and making them acquainted with what exactly the EV is. So, with that intention, we have started this particular platform. You can get connected to either to me, or you can go to our website, airaindia.com, and you will be able to get all the relevant information related to these courses through that website as well.
Yeah, so thanks, Mahesh. I think I would like to just add up to that is because there is apart from this regular 1 year courses, I've been part of the organizing through Era Academy. There are 1 month internship courses also, which are really great because in that 1 month you get a good overview of the complete system, and then you get a good understanding from the industry experts. So all these 1 month internship program where the industry experts they come, and obviously each industry experts talk about certain basics, but also talk about what is happening in the industry, where what technologies are coming and what tools are available, and how they should gear up to become a more productive or learn those things also. So that
Yeah.
those and then the SAE is another platform where they are also organizing a lot of webinars. So you should join those SAE webinar because those industry experts talk about the real world scenarios, application, and and I think you get a good, really good insights. Otherwise, it was not possible earlier. Yeah, I think Prasad, you would like to add something.
No, I think you're right. You mentioned it very rightly. I was about to say SAE is a great opportunity, and because it starts from professional bodies to, I mean, it's a professional body from students to everyone else. So I think people should take advantage there.
So
Exactly.
I just have to add one. So this particularly I have observed when I was recruiting the people. So yeah, simulation software development is a good essential skill to make a career in AV. But at the same time, my advice or my observation is, a engineer, the practical knowledge, there is no substitute for a practical knowledge. If you're a mechanical engineer or electrical engineering wanting to work in a EV, you have to be very good at practical hardware knowledge also. So there is no use of just going for a some course and doing simulation and then trying to search for a career. Practical, there is a no substitute. So I would also, like as Yogesh also correctly said, internship, doing internship, working in a SAE Maha teams. I myself was a FSUK team member when I was at IIT Bombay. So that gives you a very good perspective of what goes inside a vehicle, how things practically work. Transistor is okay, like, but how it looks, why, how not to handle it. That's also equally important things.
Yogesh sir,
Yogesh,
are you
you're on
on
mute.
mute?
Yeah, sorry. My last comment was just adding to Harshad, that I have seen in the industry the teams who work in the or the members who work in the FSA, they really get a good exposure both the simulation and the hardware side, and it's a all-rounded work. I think I appreciate the FSA teams a lot for that, and people should be part of that when they are in the academies. Yeah, probably Priyanshi, over to you.
Thank you so much, sir. So, thank you very much, all our esteemed panelists, for this wonderful session, and a very special thanks to Yogesh sir for superbly managing the session. It's not an easy task, but you made it look really effortless. And with this, we have come to an end to the virtual event. Thank you, everyone, for extending your time and support for this event. With the promise to come back with more exciting topics very soon, it's time to sign off. Have a wonderful weekend ahead.
Thank
Thank
you,
you,
everyone.
everyone.
Bye
Take
bye.
Thank
care.
you.
Thank you,
So
guys. Bye bye.
Bye bye.
Thanks. Bye.
Thank you. Thank you. Bye. Bye. Bye.